Hey guys, Ms. Gosling here. In this video, you are going to learn about standing waves. By the end of the video, you'll be able to differentiate between standing waves and traveling waves. So let's go ahead and get started. So a standing wave is a stationary wave that occur due to the superposition of two traveling waves. So the most important thing that for you guys to pull from here, we are going to talk about what superposition means, how exactly two traveling waves make a standing wave, but the key point here is that there are two traveling waves that combine together to make a standing wave. So we can never get a standing wave with only one waveform going on. So as promised, let's talk a little about superposition. So there are two key kinds of interference that we can have. So when two waves are occupying the same space, that can either result in constructive or destructive interference. Now, if we have constructive interference, this is going to occur when our wavefronts are moving in the same direction. So we can see here on the left, A and B are both above equilibrium, going to the left and to the right respectively. When they occupy the same point in space, they're going to create a waveform that is the sum of A plus B. So it's going to be twice as large as A and B. And its amplitude will be twice as high. And then, as they continue to move along their paths, they will continue to look the same as they did before they occupied the same space. So that is to say, the energy is conserved here, right? So there's no new waves being created. Instead, we're just looking at the sum of two waves occupying the same space. Similarly, we can also have destructive interference, and that is when our two waves are on opposite sides of our equilibrium line. So as you can see here, A is above my equilibrium line, B is below it. When they exist in the same space here, they will cancel each other out, because for every kind of energy that A has going up, B has the same amount going down. And then again, they'll pass each other and continue on the same way that they started. So let's briefly talk about the anatomy of a standing wave. So when we have two waves together, so we have two traveling waves together that when added together give us constant areas of constructive and destructive interference. What we get is a standing wave. And in a standing wave, we have something called a node. And a node is a place in space where our two traveling waves consistently have destructive interference. So there's going to appear to be no wave at all, no energy fluctuation at all in that space. The opposite of a node is the very creatively named antinode, which is similar to the crest of a traveling wave, but is actually a place in space where there is a constant maximum disruption, constant maximum amplitude, maximum displacement from equilibrium. So my antinode is going to be constantly moving from maximum to minimum to maximum to minimum. So it's going to be constantly moving away and from my equilibrium, whereas my node, there will appear to be no motion whatsoever. Now, you might be asking, why should I care about standing waves? What makes them special? Well, one thing that's really special about standing waves is that they have a constant frequency, a constant amplitude at all times. And so one way that you experience standing waves pretty frequently is actually in music production. So for example, a guitar generates, or a violin or a viola, any stringed instrument, is going to generate a standing wave, which is why we're going to hear that constant pitch in our waves, in our music, rather than hearing the whole kind of range of sounds that you get in a standing wave, which a good example of a standing wave, that you get in a traveling wave, like regular spoken word. Now, I know I've given you a description of how standing waves are formed, but I do think you would benefit from actually seeing their formation in action. So I have attached to this video notes assignment and a little animation of how standing waves are formed. And I'm going to recommend taking a look at it because I think that clarifies a lot of what I've been trying to talk about, to explain to you guys in this video. So let's go ahead and talk takeaways. First of all, standing waves are formed via the interference between two traveling waves. And second, a good example of a standing wave is the wave generated by plucking a guitar string. So that's really all I have for you. The next video that you're going to watch discusses some of the math of standing waves. So with that, I'm going to leave you to it. Best of luck and happy learning.